So let's start talking about vectors. So vectors are very interesting mathematical objects because they say something about a quantity. So there's scalars and there's non-scalars in mathematics. So we can say that a a equals 5, which is a scalar, and then we can say something like a vector where we can denote it with multiple notations. We can say that b equals 2i plus 2j. So this really indicates that, and in terms of notation, vectors have multiple notations. This is one of them. Don't confuse I with the complex number because I is basically the unit vector in the x direction. So I guess I'll start with more general terms. So any a good way to represent vectors, at least in the up to the third dimension, is ai plus bi, well bj plus ck, and we like to write arrows over these I, j, and k's because they denote direction. So you can imagine in the case of the two-dimensional vector, we have some vector here, which we can denote a and b because it only has two components. So there's a unit vector in this direction that we denote as I, and we have a vector in this direction which we denote as j. So obviously, if you can think that we're basically trying to make something like this. We're trying to make a vector out here. So you basically magnify uh, I and j by what's required, which geometrically would be ai plus bj. And that's because if you take ai and add it to bj, you're actually getting this point in space AB. So there's multiple ways to represent vectors. What's interesting about vectors is that they have a magnitude and a direction. Things like scalars don't have directions. They have magnitudes. It's simple. It's just 5. But these things have directions to them. You know, to think about them at least in 2D, which I'll talk about in this video, and talk about the more general case of 3D vector. If I have some vector here, there's going to be an angle and there's going to be a magnitude of it. We denote the magnitude as double brackets around the vector. So if we had r equals a plus ai plus bj, then basically the magnitude of r would be square root of a squared plus b squared, which is just the Pythagorean theorem. And then we can just say theta equals the inverse tangent of b over a. So again, you can basically represent any vector that you want. You can find out the norm, basically the magnitude of any vector with this guy and the angle it forms with the origin here with this guy. So really, vectors are very interesting creatures because you can do operations with them, and it's very important. And I'll sort of talk about this in other videos, but um, for more advanced and especially keeping in the subject of linear algebra, really, we'll think of vectors as basically an ordered pair, like a set of ordered pairs. So before I said r equals a plus ai plus bj. So we can denote that as an ordered set in R2 because this right here is R2. So we can think about this as a point AB, right? Just like a point in an XY in the plane. And more generally, we can think of just any dimensional, this is for R2. We can think as R3 to be ABC. So that's R3. And then the more general case that we're usually interested in is Rn, which with a new notation we could say x1, x2, blah blah blah, xn, and that's not equal to. That's basically the ordered pair for Rn. So this is good notation for linear algebra and usually how we talk about it. So in the next video, I'll start talking about matrices.